Hi everyone! In this tutorial we are going to create an abstract neural network with a simple node system. As you know, I always try to create complex systems in the easiest way possible to show you that Houdini is easy and for you to feel more comfortable with this fantastic software. Before we start, don't forget to hit the subscribe and like buttons to help our channel. Hope you enjoyed this Houdini and Redshift tutorial, and let's get neural. Okay, let's start our neural network. Let's put a geo. Let's call it neural. Okay, let's dive in. Let's place a sphere. Let's give it polygon and high frequency. Let's go with 40. And we're going to giving it high frequency because we are going to paint our sphere. Why is that? Because if we place scatter now, it will scatter points uniformly on the surface, and I want to scatter points depending on the color. Okay, so let's put a point VOP, and let's color those points. Let's use turbulence. Okay, and let's link a ramp between the turbulence and the output. Something like that, and let's create input parameters. Okay, let's go up and let's work here. Okay, so now go with sparse, more blobby. So let's decrease this to have more blobby shapes. Let's maybe increase the frequency like that. Something like that. I have a huge blob here. That's too much. Let's try another one. Okay, that looks cool. So now let's put a scatter, and you will see that the scatter points will scatter depending on the color. So now, as you can see, if I increase this, let me turn off the relax. Increase this, you can see we are scattering only on the white, not the black points. Okay, that's better. And now let's delete that attribute. Let's delete the color. We don't want that. Okay, so we have cool points. Now, I think maybe that's way too big for our initial simulation. So let's put a transform. Go something like 0.2. Okay, pretty cool. So now let's start using our first popnet. So as I said, we are going to use only popnets to create this neural network, and you will see it's pretty simple. So let's dive in. Let's come here. Let's go to all points. So we are using those points. And the birth, I just want to birth on the first frame. Simple. And let's put a VOP, pop VOP. Let's add a parameter. I'm going to use a curl noise. Okay. So I like to, when I use, when I use noises, I like to use a parameter to multiply that noise. You can use the amplitude, but I like to leave the amplitude at 1 and adjust on the curl force. Okay, so let me show what I'm saying. It's easier. So let's put a link to position to our curl noise. Okay, let's go with that and multiply. So the force is a float, so always link the vector first and then the float on the second input of the multiply. And let's go here and link to the velocity. Okay, simple as that. And on our curl noise, let's create input parameters. Go up. So here we have our curl noise. Let's see if we got everything. Let me just copy relative because I just like to work in one. And let's see how it goes now. Okay, pretty cool and pretty crazy. So now let's turn these into trails. So for now, because we are not killing any trail, okay, because we are not killing any particles, we can use this node. In the next one, in the next popnet, we can't use this trail. Okay, so let's see the trails. Let's go to connect its polygon and check close rows. And here, let's go with $f end. So we are using the frame. Okay. So we have here, let me change this to black background so it's easier to see. So we have a lot of trails. Okay. I think that's way too much. So let's go with maybe 2000. And I can see this is pretty crazy. So let's go to the popnet. And here is a little trick. Let's fix this viewport to see always the trail. Okay. So when we go inside the popnet, we don't lose that viewport. Okay. So it's easier to preview our final output that we want. Let's change this to 0.6. I think it's a good scale. Roughness, let's go to 0.25 and turbulence 2. Let's try that. Okay, that's pretty cool. Maybe it's way too chaotic for my taste. So let's try and reduce the scroll force. Okay, they are starting to gather. And only after a while, because we reduce the force of the curl, it's changing. Let's go to the last frame to see the final one. Okay, now it's way too clean. maybe let's change this to 0.7. Go back to 5. Let's leave the turbulence. Go review the last one because we want the final rails. Okay, that is cool. Maybe if you want more chaotic like I have on the preview, on the introduction, let's try and change this to 4. See if this updates. Nope. Go to last frame. Okay. Much. Okay, I think that's a good one. Let's go with this one. That's cool. We have some uniform rails, but then we have just a little bit of turbulence. That is cool. So we have our final trails. Okay, so let's go here and let's cache this last frame. Okay, so let's go here and let's go neural trail cache. Okay, and here we don't want the $f and we don't want the heap name. And I just want to cache this last one. Okay, so save to disk and load from disk. Okay, so now we have our neural. And if I scroll on the timeline, we still have the complete trails. That is what we want. So now we want particles to go on each trail, right? So how do we do that without vex and a simple system? That is pretty easy, and I'm going to show you how. We just need to drag this popnet. We don't change anything, okay? And because it is using the same curl, exactly the same curl, it's going to follow the same lines because we are not changing anything. We are not changing the initial positions, okay? And we are not changing the curl noise, okay? So it will emit particles and they will follow exactly the same trails. That's pretty cool, right? So we just need to change here a few parameters because now we want to emit particles on the first frame and then each segment of frames. So let's go with emit on the first frame, or where is the R? Let's go with each emit frame for each 40 frames, okay? Something like that, close to 0. Okay, I've explained this on the other tutorials. This is a model. So every time the frame number divided by 40 don't gives you an integer, not a float, it will emit. So right now, let's see how it looks. And to see that, let's put a sphere. Okay, let's copy the points. Just check if this is working. And let's merge everything to see if this is really working. Now, way too big. Let's put 0 0.1, 0 0.05, 0 0.01. That looks cool. And let's give a color. Oh, right. This is way too big. Okay, something like that. And let's see if this works. So as you can see, we emit particles. And now, as you can see, on each 40 frame, we will emit. So if I go to 80, we'll emit another one. And as you can see, let me go close. The particles are following the trails again, because we are not changing anything. We are not changing the initial position of the points, and we are using exactly the same curl. We are not changing anything here. Please don't change. If you change just a parameter like the curl force or the offset, they won't use the same curl noise, right? So this is a simple trick to give you particles following the same trails. Okay, so this is pretty cool. Maybe we are emitting way too much particles, so let's change here. The only thing that we want to change is here, go to 80. If like this is better. Okay, pretty cool. So we have a bunch of particles, and that is cool. You can even come here now, because we locked the trail system to that current frame. We can come here and change the frame range, and we keep emitting particles. But you will see a problem. That's why I changed particles. Even when they finish the trails, they keep going, because remember, we did the previous trails only at 300. Let me change here to 300. It was the previous one. Okay. And those particles, some of the particles have like 20 seconds. We need to kill those particles so we don't have this red cloud, this point cloud outside our trails. So let's come here on the life expectancy. Let's kill them at 10 seconds, because I'm working with, let me show you. I always work with 30 FPX. So 300 is 10 seconds. Right now, if I go up, let me go to close to here. Okay, we see the particles. Let me go and look for a finished trail. Okay, so you will see those particles will die. Okay, that is cool, because they only have 10 seconds. When they hit the last trail, they die. Whoop. Okay, cool. That is cool. So now, what can we do more? If we look at these trails, they don't look organic enough, because they are static. They are fixed to one point. Okay, we emitted the particles, and then it's kind of boring like this. Let's move a little bit of movement to our trails and our particles. And by adding a movement, we want to be sure that the points are stick to the trails. So we need to do that after all the simulations. So now let's go here and let's use a simple VOP. Okay, let's use a point VOP. and add movement. Okay, let's go here and let's add a flow, materialize flow noise. Okay, why do I like this one? Because it looks super organic and we can use a fourth input. Okay, a 4D input and output a 3D noise. Why is that? Because now I can use time to animate the noise. So let's go and do that, vector to vector 4, because now our position needs a vector 4. Okay, and this one I want the time, but I want to control the time of the noise. Okay, so let's add a multiply multiply constant, this one. Okay, multiply constant, let's go here and let's change to 0.2 or 0.5 of the, let's slow motion this, right? And we have our flow noise, so now we need to displace all the points. So let's go add and let's create a displacement. Okay, pretty cool. Now if I press play, you can see all our network is moving. Pretty chaotic for now, but you will see, let me go 50, you will see that our points are still linked to the trails, even with all that movement. Why is that? Because, as I said, we have the static animation, and because we are working only with points, we can add a point swap and displace those points. Okay, and everything will work together. Now let's clean a bit that movement. If you like this chaotic, I don't like it so much. So let's try and maybe 3. Okay, and amplitude 0.7. And I think the frequency, maybe the frequency. Okay, pretty. It's not so chaotic as it was. It's better for my taste, but it's up to you. Again, I'm just explaining the system now. You are directing our stuff. But now I think it's way better to see this movement, and maybe it's way too strong. I think the animation of the noise is way too fast. Okay, and 0.7 is cool. The roughness, go with 35. Just break a little bit. And the frequency, let's dial this down a bit. Oops, that's way too much. And let me relative, relative, relative. But here, way too much. 0.8. I think that looks cool. So now let's see how it looks. I think that's pretty cool. But I want to show you something else, is that for my taste, I like things, and we are going to look, this is going to look macro. So the particles, I think they are moving way too fast, okay? I don't really like these fast movements. So what I want to do is use time warp to slow motion everything, okay? So what I'm going to do is paste here a time warp. Paste here a time warp. And I want the output to be between 1 and 600. But here I want just a close, maybe 350. They will be really slow motion. Let's use interpolate to be better. Hey, they are much, much slower. Yeah, I like this way. If you want even more, that up, as you can see, they are moving way too slow. I think that's cool. almost of the speed that we had. And it is important to use a time warp and not come here and change the curl force, because again, we can't change this pop warp. Because if we change anything on that, the particles will not follow the trails. Okay. So now, again, because we did the time warp before the add movement, it will still work. Now let's see. Our neural network, it has some organic movement. That is cool. And we have those particles, okay, moving with slow motion. I think it's way better than static one. Now, what we can do, uh, let's, instead of emitting points, right? Instead of emitting points, let's emit trails. And how can we do that without this trail? Let me show you why we need to avoid this. Because if I use now a trail, okay, and I want to create polygon like we did, I want to create a spline, and I want to use like 6 frames. When the particles die, the trails is using I think it's this ID, okay? But when the particles die, they don't process that in a good way. So let me try and look here next to 300. So they are emitting. And as you can see, when some particles start to die, they kind of mess up. And this is not really good. You can see. Every time the particles die, the trails kind of messed up. So let me show you another way to do that. Let's come here and create a wrangle, point wrangle. And here on this wrangle, I need to save one attribute, okay? I need to save this ID attribute, not this one, okay? This ID attribute. So let's create a new one. E for integer, add to create a parameter, and let's go with the starting ID. Just simple like that. And I want to be equals to the currently ID, okay? As you can see, where is it? Starting ID. Okay, this one. It's always the same. Okay, even if they die, they will stay the same. Okay, because after a while, let me go and see. As you can see, this ID, this particle has the ID of 2000, but the ID on the system is 0, on the point number is 0. It's not really that good to use the point number as the trail uses. Okay, so now let's go and put a popnet, and we will use a popnet to create our trails. So let's go here into this popnet. Let me go and create popnet small trails so you won't get confused. And let me do this here. We will still need. Okay, on this popnet, we go and check that. On this popnet, I want to emit on all points, and I want to emit every single frame, but I want them to die. So let's go with 1 second, so 30 frames on my current setup, and you see something is messed up. What is that? What is messed up is the attributes that we are getting from the original particles, because the original particles have initial velocity, so we don't want that. So let's really focus on that. Let's see if this works. And now you will see that particles won't die because, again, the original particles have life of 100. If we go up, the current one, you can see that our particles have a life of 10 seconds. And now we want the particles to die after 1 second. Right, so here, let's delete this dollar. And we want just the position and the starting ID. This is really important, and you will see in a bit why. So right now, our new particles just have a position, just have an attribute from the original, no velocity, no life, and the life is just 1 second. Okay, now you will see that it will look much better. Okay, so now we have cool trails. These trails are way too big, so let's go with 0.2. Even 0.2 is way too big. Something like that. Just a few trails. So now, what can we do with this? Because we want splines and not points. That is easy. Let's use an add. And that is why we created this starting ID, because every single trail, they have the same starting ID. Okay. So now let's go to polygons, by group, use attribute, and here let's use this one. Okay, so copy, and let's go here, starting ID, and now we have our particles. Pretty cool. We have now splines instead of single points. And you can even use a resample. I'm just putting this in case you want. Move this down. Okay, you can put a resample, have 10 segments, and output or create a curve U in case you want to color them out or give different p scales. Okay, so now everything is cool, and we can time warp our particles. Cool. Now mix everything because we can't really see them now. We could come here and put like this to see our points. And let's add the movement. That's pretty much it. So now let's go and let's delete this one. Okay, so we have our particles, and let's create now two nulls so we can go to the rendering part. I like to use a blast. Okay, so here I want, okay, so we need to group. Let me group the particles, the trails, sorry. Let's go group. These ones, let's call it moving trails. Or let's go with neural signs. Okay, we are emitting signs. Let's change to points so we can group that out. Apply the add movement and then blast. Now we can draw signs, delete not selected. Let's go with null. Let's go without neural signs. And let's alt drag these, and here on this one I want the trails. Here is out neural network. Okay, that's pretty much it. Let's go up and let's place a geonode so we can create different materials. So let's go here, let's put a merge, object merge, let's pick up that out neural sign, accept. Now we have those. Pretty cool. Let's go up, let's save the project, and let's start on the rendering. So let's start by changing the UI. Let's change to this one, as you know. Let's change the dark background. Okay, pretty cool. Let's place camera somewhere else. Let's change this to Full HD. Let's lock. Let's go to the camera and let's go for a really nice go. Something like that. Let's see if we have arrows. Okay. Lines here. Something like that. Yeah, I went from the start. This is pretty tricky to pick a nice one because we see only lines but let's go with this one. Okay, so we have our camera. Let's put some HDRI, Redshift, pick some HDRI. Let's go pick some, go something Star Night. I don't know what that is. Okay, that's pretty cool. You won't see it. It's just to give a few reflections, right? And I want to put a light. Let's turn off the visible. I always hate that checkbox. And let's go with the light. Let's see, where is the camera? The camera is pointing that way. Let's put something like this. Okay. Let's alt drag that light. Let's change to light number 2. And this one, I want something like 0.2. Like something like. Okay, so let me show you how the lights look. Very cool. Now let's kill the lights, okay? Because I just want to control the intensity after we check the render. Okay, that looks cool. Now let's create materials. Let's go Redshift. This one will be the network. And this one will be lines. Okay. And this one, let's put a material. And this one, let's put another material. And just let's call turn off the diffuse, because we are going to emit on this one. Let's go with 20 and something like 3. Okay, something like that. But I won't go and divide this case, because we just have 2 materials. So this one is the signs and this one is the network. So we can quickly select different materials. And here on the neural, let's pick materials that we want. Here is network, and here signs. Okay, redshift, strands. Let's go with cylinder. Ignore p-scale, and we will see how this will work. Let's go with something pretty small for now. Cylinder. I don't like to work with strips, because strips are kind of planes. They look 2D, so we will lose a lot of details. Ignore p-scale, and let's go with this for now. Okay. Go increase the tessellation. Let's save. And now the output, let's press Redshift. And quickly, I just like to do for a quick setup. I just like to go with brute force, double brute force, 6, 20, 10, 24. Simple. And because I have 3090 RTX, I'm turning on this enable optics RT. Okay, I think that's pretty much it. And let's see how it looks. Let's go to our render view. Building the scene. Something that is cool, and something like that. Don't really like the dome, because the dome is giving those red lights. Let's try and change this to that. If I want a bluish tone, let's see if better. Ooh, that's too yellow. I don't really remember which one was it. It's the blue one. That's not bad at all. I call this down. Just not blue, but can work with that. Let's see. Or maybe let me go and pick another one that I have already. Download mother objects. Go with pink for my taste. So let's go again with the Haven. Those are free, so you can download them, and I want you to be able to follow these. Now we can turn on this. Let's go. This is the main one. As you can see, it's way too big. Go with 5. Let's see what doing. Really nice reflex. Go with this one. Move this one. The other. So this. Oops. Camera. Okay. Like this. Okay. That is way better. And we can increase this a bit. Okay. That is pretty cool. And we can change colors. Okay. Something like that. Let's go with that. Now let's change a bit the materials, because now we only see the trails. So let's go to the materials. Let's start with our reflection. Let's go with something bluish. Christy can kill it a bit. And here 6, 8, okay, 0.8. Increase this. Okay. That is starting to look cool. Let's add a sheen. I like to use a sheen and have a different color. Okay. It's more off. Give a little bit of contrast. Okay. That's pretty cool. But now we are going to use refraction. Bump that out. Pretty cool. Now let's add this 6. Okay, we are starting to look something. Okay, pretty cool, pretty cool. Maybe the trails are way too big, so we can always come here to these popnet trails and reduce. Pause this before it crashes. So now let's go to a different frame. Go up, up. Okay, let's go and preview again. Okay, that is cool. Starting to look way better. So now, a bit more bluish. Okay. That is cool, right? We can boost this a bit. They are way too small. Let's see how it looks. It's way too big, sorry. Again, still too big. Maybe it was cool, 0.01. 001. Okay, that is cool. And now our signs are off the side. Oh, that's cool. Okay, so now it's up to you to change the position, and even now I don't really think, see here, maybe call it more samples, give it more samples. Hey, that is cool. Like to give a bit of roughness, you can see there. And let's go and see another less chaotic zone. Go and try to up a bit. Okay, cool. Okay, I think this looks cool. And let's change the light back to yellow. To white, sorry. Okay, that is better. Now what you can do to look more as a neural network or a macro shot is come to the camera, Redshift tab, and let's work with depth of field. So what I like to do is to uncheck that and control here the focus distance. This is a pretty small system, right? A project. We are working with really small numbers. It's kind of tricky to pick right values, but it is possible. Let's see. So now we are focusing that part. Let's try to focus this one. To big. Look. Yeah, we are close. Let's go 1.7. That's pretty cool. Dial this down a bit. Hey, I think that is cool. It is. That's cool. Okay, so I hope you understand basic setup. Create a neural network, add a little bit of movement. Chaotic. Let's try and finish the tutorial with a nice frame. Go back to 0.2. Try to pick those. Oh, that looks cool. I like it. Now, dial. That's pretty cool. Bigger scale. See how it looks. And as you can see, this was a pretty fast system with a cool network. That is cool. I've lost it again. Macro shot. Focused. Okay. That is cool. That is pretty cool. I hope you enjoyed this one. It was super simple. Let's recap really fast. So we created first this part. Okay, so we created the trails. Okay, one little tip is that I created way too much particles on this tutorial on the start. I think on my project I had like or 500 or 1000. So that's why we have a dense neural. Okay, so we give a curl noise at our taste. This is the main part, the main art direct part. We give trails and created a cache to be faster. You could put just a time shift, but that is one way to create it. Then alt drag, create your popnet, create the trail system. Okay, time warp for slow motion group, then add movement, that organic movement to our entire system without moving the particles or the trails separately. Okay, then I just blast because I want to give different materials for each system. So that's pretty much it. I hope you enjoyed this cool simple tutorial and have fun playing with that neural network. Don't forget to share with us your result, just tag Doxia Studio on your social network. As always, check our Patreon page and support us to keep doing these Houdini tutorials. Have fun and see you at the next one. Bye bye!